Have you ever stopped to think about the sun? That bright, glowing ball in the sky that rises every morning and sets every evening. It's easy to take it for granted. But the sun is far more than just light and warmth. It's a powerful star, a giant nuclear engine, and the reason life exists on Earth at all. Today, we're diving deep into the fascinating world of our sun, how it works, what it's made of, how it shapes our planet, and even how it can sometimes put our technology at risk. The sun is a star, just like the billions of stars you see in the night sky. It sits at the center of our solar system, holding everything, planets, moons, asteroids, and comets, in orbit through its powerful gravitational pull. It's made mostly of hydrogen, about 74%, and helium, about 24%, with small traces of other elements like oxygen, carbon, and iron. The sun's enormous gravity comes from its incredible mass. It contains 99.8% of all the matter in the entire solar system. That's right. Almost everything that exists around us, including Earth, is just a tiny fraction of what the sun holds together. At the sun's core, temperatures reach an unbelievable 15 million degrees Celsius. Here, hydrogen atoms are squeezed together under extreme pressure, fusing into helium, a process known as nuclear fusion. This reaction releases massive amounts of energy in the form of light and heat. Every second, the sun converts 600 million tons of hydrogen into helium, releasing energy equivalent to billions of nuclear bombs. That energy then travels outward through the layers of the sun, from the core to the radiative zone to the convective zone, until it finally escapes from the photosphere, the visible surface of the sun. From there, it travels through space at the speed of light, reaching Earth in just 8 minutes and 20 seconds. The sun may look like a smooth golden ball, but it actually has several complex layers. Core, where nuclear fusion happens. Radiative zone, energy slowly moves outward, sometimes taking thousands of years to escape. Convective zone, hot plasma rises and cool plasma sinks, creating bubbling motions. Photosphere, the surface we can see, it's about 5,500 degrees. Chromosphere, a reddish layer visible during solar eclipses. Corona, the sun's outer atmosphere stretching millions of kilometers into space and visible as a glowing halo during a total eclipse. These layers constantly move, change, and send waves of energy across the solar system. Without the sun, there would be no life on Earth. Its light provides energy for photosynthesis, the process that allows plants to grow and produce oxygen, the very air we breathe. The sun's warmth keeps our planet's temperature stable, allowing water to remain liquid, a key ingredient for life. It also drives our weather systems, causes ocean currents, and powers the water cycle, evaporation, condensation, and rain. But the sun doesn't just affect our environment, it also affects us. Exposure to sunlight helps our bodies produce vitamin D, essential for healthy bones and immune function. It can even improve our mood, helping fight conditions like seasonal depression. In short, we owe our very existence to the sun. The sun isn't calm. It's full of activity and magnetic energy. Sometimes powerful eruptions called solar flares or coronal mass ejections, CMEs, burst from its surface. These events release charged particles that travel through space, sometimes reaching Earth. When they hit our magnetic field, they can create stunning light shows known as auroras, the northern and southern lights. But these solar storms can also disrupt satellites, radio signals, GPS systems, and even power grids. In 1989, for example, a massive solar storm knocked out electricity across parts of Canada for 9 hours. Scientists study the sun's cycles, which peak about every 11 years, to predict and reduce the impact of such storms. Because the sun is so powerful, looking directly at it without protection can cause permanent eye damage. That's why scientists and educators from programs like HEAT, the Heliophysics Education Activation Team, teach people how to observe the sun safely. Using solar filters, eclipse glasses, or telescopes with special lenses, anyone can watch sunspots, solar eclipses, and flares safely and learn more about our star. The HEAT team also educates communities about how solar activity affects Earth and our technology, making solar science exciting and accessible to all ages. Like all stars, the sun has a life cycle. Right now, it's about 4.6 billion years old, and it's in its stable main sequence phase. But in about 5 billion years, it will begin to run out of hydrogen fuel. At that time, the sun will expand into a red giant, possibly swallowing Mercury and Venus, and maybe even Earth. Eventually, it will shed its outer layers and shrink into a white dwarf, slowly fading over billions of years. Don't worry though, humanity has plenty of time before that happens. The sun is like a giant magnet. Its surface boils with electrically charged gas, creating powerful magnetic fields that twist and tangle over time. These magnetic fields are what cause sunspots, dark, cooler areas that appear on the sun's surface. When the magnetic energy becomes too intense, it can suddenly release, creating solar flares or eruptions of plasma. These magnetic patterns constantly change, flipping completely every 11 years, marking the start of a new solar cycle. Scientists study these magnetic shifts to better understand how solar activity affects Earth's weather, communication systems, and even astronaut safety in space. The sun's magnetism is one of its most mysterious and beautiful traits, invisible to our eyes, yet shaping much of what happens in our solar neighborhood. The sun is the main driver of Earth's climate. Its energy powers wind, rain, and the changing seasons. Small variations in the sun's energy output, called solar irradiance, can slightly warm or cool our planet over decades or centuries. For example, a long period of low solar activity in the 1600s, known as the Maunder Minimum, coincided with unusually cold winters in Europe, a time sometimes called the Little Ice Age. However, scientists are clear that today's rapid climate change is caused mainly by human activity, not the sun. Still, understanding how solar variations interact with our atmosphere helps researchers make better predictions about long-term climate patterns on Earth. Just as we have weather on Earth, space has weather too, and the sun controls it. When the sun releases charged particles during solar storms, they fill the solar system with streams of plasma and radiation. This space weather can damage satellites, harm astronauts, and interfere with spacecraft navigation. Agencies like NASA and the European Space Agency constantly monitor the sun using special satellites such as SOHO and Parker Solar Probe. By studying solar winds and magnetic activity, scientists can issue warnings, just like meteorologists do for hurricanes, to protect our communication systems and astronauts in orbit. Space weather reminds us that the sun's influence stretches far beyond our blue planet. For thousands of years, humans have looked up at the sun with awe and respect. Ancient civilizations, from the Egyptians to the Mayans, worshipped it as a god of life and power. Temples were aligned with sunrise and sunset, and solar calendars helped early farmers predict the seasons. Even in modern times, the sun remains a symbol of light, hope, and renewal in art, religion, and literature. Across cultures, it represents strength and rebirth, from Japan's land of the rising sun to the ancient Egyptian deity Ra. While science has revealed the sun's physical nature, its emotional and spiritual influence on humanity continues to shine just as bright. In recent decades, scientists have launched remarkable missions to unlock the sun's secrets. The Parker Solar Probe, launched by NASA in 2018, is traveling closer to the sun than any spacecraft before, within just a few million kilometers of its surface. Its instruments measure heat, radiation, and solar wind, helping us understand why the sun's outer atmosphere, the corona, is hotter than its surface, a long-standing mystery. Other missions, like Solar Orbiter, capture high-resolution images of the sun's poles, where magnetic fields are born. Each discovery brings us closer to predicting solar storms and understanding how stars evolve throughout the universe. Though it feels massive and eternal, our sun is just one of over 100 billion stars in our Milky Way galaxy, and a fairly ordinary one at that. It's classified as a G-type main sequence star, or a yellow dwarf. Compared to giant stars that burn blue hot and die young, our sun shines more steadily, living a calm, long life of about 10 billion years. Its stability is what made life on Earth possible. Studying the sun helps astronomers understand other stars, how they form, live, and die, and offers clues about which planets beyond our solar system might also host life. In many ways, the sun is our cosmic laboratory, teaching us about the universe itself. The sun has always been our greatest source of life and energy. Every living thing on Earth, every plant, every ocean current, every heartbeat exists because of its light. Even the fuels we burn today are ancient sunlight, stored in Earth for millions of years. But now, as our planet faces pollution and climate challenges, our relationship with the sun is changing. We are learning to harness its power directly through solar energy, turning sunlight into clean electricity. In just 1 hour, the sun sends more energy to Earth than humanity uses in an entire year, energy that could sustain our future if used wisely. The sun also continues to inspire exploration. Missions like NASA's Parker Solar Probe and the Solar Orbiter are revealing new mysteries, from the sun's burning corona to the forces behind solar flares and magnetic storms. This knowledge helps protect our satellites, astronauts, and technology from space weather, and deepens our understanding of how stars like our sun give birth to life. Beyond science, the sun has a profound impact on our emotions and culture. It symbolizes hope, rebirth, and light, guiding humanity through every age. Its steady rhythm of sunrise and sunset gives meaning to time itself. In the future, solar energy could power our cities, homes, and even spacecraft exploring distant planets. Imagine a world where clean sunlight fuels everything, where the same star that sustained the first humans now drives our journey beyond Earth. The sun reminds us of our origins and our possibilities. It shows that nature holds the answers we need if we learn to understand and respect it. Every sunrise is a reminder that even in the darkest moments, there is always light waiting to return. The sun doesn't just shine above us, it lives within us, guiding our progress, inspiring discovery, and promising a brighter, more sustainable future for generations to come. As the sun sets beyond the horizon, it reminds us of a simple truth. Every ending is the beginning of new light. Its energy flows through every living thing, connecting us to the universe itself. The sun will rise again tomorrow, and with it, endless possibilities for our future.